Everyone, today I just thought I'd make a quick video basically on my opinion on why the DeepSeek R1 has superior performance at these reasoning capabilities. It's made a lot of headlines in the news, and I thought it was really interesting, so I just want to talk about it pretty quickly. So the main key takeaway, they even say this, they outline this explicitly in their paper, there is no supervised fine-tuning. That's kind of the key. You can kind of, if you're just looking for the video, I appreciate you clicking on, you can just go ahead and leave, because that, again, that's the key. If you're familiar with AI models, basically we train a large amount, this super massive model on just a huge amount of raw data, and we just teach it to learn to model language in a mathematical way. And then what we had been doing, and I think we're going to move away from that, especially for these reasoning tasks, is we had essentially fine-tuned or tried to improve the model by basically giving it questions and answers. And so we trained this super big model to just mathematically model language, and then after that we tried to adjust those models by saying, okay, if I give you this question, I want you to answer it like this. If I give you this question, I want you to answer it like this. And that's kind of very costly to have somebody. Essentially it comes down to, at the end of the day, a human will have to label, this is the question that we want, this is an answer we want, and you'll have to go through a lot of processes. And we'll see that I believe that this is the reason why the DeepSeek is so much better than ChatGPT, for example, which does use a supervised fine-tuning, because it's actually, when you're not giving those explicit instructions of this is a question, this is the answer, you're actually forcing the model to reason through the arguments, and we'll see the consequences of that and how that ends up being a lot easier. So it uses the reinforcement learning and chain of thought, which basically it's just iterating off of itself. So again, instead of labeling this is the question, this is the answer, it's actually forced to actually think and go through it. And it also does talk about a little bit about distillation, which we'll just get into just briefly. So this is just a graph. Basically, you can just see that it just kind of is good at things. It's just as good as as OpenAI for a lot of these tasks, specifically these reasoning tasks, but it is a fraction of the cost. So OpenAI, the biggest model takes about like $60 per, I think, every million or 100,000, I think it's a million tokens. The comparative one for DeepSeek R1 is about $2.12 or something like that. So it's more than a tenfold decrease in the cost to have pretty much the same performance, or if not even a couple times more superior. So it's a pretty big deal in that it just how cost efficient it is, not only to train it without that supervised fine tuning, but also to be able to run and evaluate the models. This is, again, exactly what they're saying. They're saying we directly apply reinforcement learning to the base model, which in this case was their V3, which, to be honest, was not as good of a model. I mean, they came out with it. It was open source. It wasn't as impressive. It didn't make the news because it just wasn't that good, to be honest. But then they built that base model, and then they trained it using just the reinforcement learning without any supervised fine-tuning. And that was the key, because now they even say this breakthrough paves the way for future advancements in this area. And this is an example of, it's just like you give if someone's learning calculus, you can either just give them a bunch of questions and a bunch of answers, and maybe they can actually do pretty good on figuring out how to backwards engineer it. But when you force them you don't actually give them any of the questions and answers, or you give them the questions and answers, but you don't force them to adapt their model. Basically what will happen is, and you can see this, we'll talk a little bit more about in a second, it'll actually think, and it'll show, it'll show its thought processes. And they call this the aha moment, that they notice that the model, without actually training it to, will back up on itself and actually see, okay, was that the right thing to do? In this case, this is just a kind of a simple math problem. They start by squaring both sides here, and they get this, and then they could choose to expand it out, which really isn't as efficient. It's still right in the sense that if you do, like mathematics, you do the right steps, you will get the right answer. But they actually noticed there's a kind of more elegant way to solve it. You can just square both sides again. So they didn't actually teach it to think back on itself, but the consequence of not explicitly giving, hey, this is the question we want, this is the answer we want, and actually forcing it to reason through itself. When I say reason, I mean like that reinforcement learning model, that chain of thought model. It's actually forcing it to learn how to do these math problems, as opposed to, oh, this was the question they wanted, this is the answer they give me. And so it's a little bit small. You can pause if you want to just read a little bit more, but I'll just so on the left we have the DeepSeek model, on the right we have the OpenAI model. I basically just asked it for a Python problem. I wanted it to do some things in Python, just a classifier on top of another LLM. I was just curious to see how it would respond. And you can see that the DeepSeek really, it gets into exactly how it thinks about the problem. And it's almost like talking to like a person. in a very different way. If you look at the AI model, it's just, here's your code. And then it kind of explains some things. The code is rudimentary. I'm actually I think I might make another video. I'm not sure yet. I actually was curious to see how the outputs of these codes. So at the end of this, it gave me pretty nice looking code. I mean, I can't tell from just looking at it. I'll have to go into it a little bit more. But this is just a really good example of, you can see that the one on the right, which was the OpenAI model, it really just gave me the answer. It just said, I just asked it the question and it gave me the answer, because that's kind of how it had been supervised and fine-tuned. It had been supervised to say, okay, if I give a question like this is the answer you need to give. Where in contrast, none of that occurred in the DeepSeek model. It was actually forced to reason out every single step. And that's why that we're getting that superior performance, or at least a very close performance with a fraction of the model size, because I think that that's the key. Really, we don't have that supervised fine-tuning, and it's allowing itself to actually think in more of a sequential way, as opposed to just, again, be given the questions and the answers. We can actually see here, so I know that there's a lot of talk on the internet, but really, in my opinion, it's showing that it's just better in math. It's honestly just kind of looks like strictly better in math. But, in things like English or, other things, maybe code, it still needs a little bit more work. So it's not, I think there's a lot of headlines that may show, oh, it's just OpenAI's killer. I don't think that's the case. I just think for these specific kinds of problem, and math is a great example of one that requires this step-by-step sequential thinking, which, again, you're not giving it. It's just, again, like the calculus student, it's not helpful to just give a bunch of questions and a bunch of answers as it is to sit there and force it to go through each step and force it to actually identify it. And that's kind of really the key, is because it more closely actually relates to how people reason, or how reasoning should be done. Because reasoning is not done by looking at questions and answers. It's done by even just looking at one question and answer and forcing yourself to go through it and learn every single step. And the other example, I think, that may not be as common, but I really believe this is the case. I'm not going to get too political here, but when you think about the way that Western data and Chinese data are kind of available, anybody can go on Twitter and buy pretty much all of the data on Twitter if you have enough money, and it's not even that expensive. They're really just giving it out to anybody who asks. Chinese data, I tried to go get data from Weibo and from Jihu, and it was very difficult because they do not want you scraping their data. They don't want other people to have their data. And so, when this Chinese company comes out, they have this huge wealth of access of Chinese data, plus they have all of the Western data. They also have all of that. Whereas Western data really pretty much is just based on Western data, and there's not really much interaction with the Chinese internet. So they're just strictly working with more data here. And that's, I think, not really being talked about, but at least from my personal experience working with Chinese and Western data, they're a lot more cagey about who they give their data to and how accessible that is. And they just have, I think, way more access to data, because they still have everything that the West has, but they have this, 1.3 billion or however many people in China data that they own, that the government will give them. And it's just a lot easier. Finally, they talk about distilling a little bit, which I thought was just a little bit interesting. So distilling is just making a model smaller. And they talked about, they looked at two different ways. You can either start with a smaller model and try to do this reasoning and try to do this large-scale reinforcement learning, or you can start with a huge model, reinforcement learning, and then distill it to a smaller model. And they pretty much show that the second one, where you actually have a really powerful model, you train a really, really powerful model, and then you distill it, seems to be a little bit better than starting out with a small model and trying to force that to do better. And so I think that this is going to be a case where it's just an interesting observation. So it seems like you'll still need to have this huge model. You'll still need to spend these 2.3 million at least hours on GPUs to get your nice model, especially your base model, and then your reinforcement learning model. But once you do that huge model, you should be able to distill it, and it'll be a little bit better. And they showed that they had some pretty good performance on the distillation. So those are just my takeaways. Again, the key, I think, was, even they said this, the lack of supervised fine-tuning. It just makes so much sense why all of the reasoning tasks and things like math are just way better, or way more accurate using the DeepSeek R1. And just my personal experience going through the, just a couple of experiments asking it reasoning-based tasks, it's pretty obvious that, that it's thinking more, it's actually reasoning more, as opposed to just getting a question and an answer, which is kind of what we were doing. So it makes a lot of sense. I just thought it was really interesting. So I hope you enjoyed the video. Thanks.